Hi, everybody. The future of product lifecycle is definitely evolving. AI, automation, agile, and beyond. So, how do top companies and their leaders stay ahead of the curve? Welcome to All About Accelerating Products, the podcast where we dive into the minds of industry leaders to uncover proven and practical strategies for speeding up product development, finding product market fit, improving time to market, and doing it without sacrificing quality, compliance, or cost. And that's a lot. Along the way, we're going to hear some real life stories from founders and product leaders to help you stay ahead in today's fast paced and innovative world. I'm Chris McHale, CEO and co-founder of SBK and Associates. And with me today as my guest is Charles Hardin, who is currently the Senior Director of Software Engineering at RedoxBlox, a company that's creating renewable energy management solutions for industrial applications. And I am so excited to talk to you about all of that. First of all, Charles, thank you so much for taking the time out of your, I'm sure, very busy day to join us and share some of your wealth of experience and knowledge with everybody here. Okay. Let me just say a little bit more about you so people know who you are. Okay. Charles is this, as I said, the Senior Director of Software Engineering, currently at RedoxBlox. And he brings over 20 years of experience in product lifecycle and delivery. So Charles has focused his career in new markets and green technology, something very dear to my heart. And he uses his engineering expertise across networking, storage, distributed systems, and infrastructure to help scale startups into public companies. Charles graduated from Carnegie Mellon University and has most recently joined companies to work on green technology and integrations, recently at ChargePoint for EVs, and then right now at RedoxBlox, which is a company focusing on decarbonization. And we're going to definitely jump into all of that in a little bit and ask a bunch of questions there. But let's just start with some good stories, Charles, because those are fun. Before we dive into the specific questions, I like to ask people, can you tell us about the greatest product development success story or experience you've had during your career, anytime in your career? And also, how about the greatest failure that you've ever had and what you learned from it? So have at it. Let us know. You start with success if you want.
Oh, sure. I mean, the irony is it's been a very long career because I could almost jump back to one of the best success stories was when I started my very first consulting company at the ripe old age of 17. It was basically a computer tech support company for my hometown in Las Cruces, New Mexico. Obviously, a major tech hub, so you can see that technology is like second nature to everyone there. Um, and so the major success story was actually this poor lady had pretty much like lost her entire data sheet for an office, and they were just like back in like Lotus Notes and Lotus 123 spreadsheets, and I actually recovered it. And just because I
Cool.
happened to find that she didn't realize she had saved a file for something else, and and like I said, the reason why that was there because it was the first thing like, oh, you can actually help people, like you can actually do
Mhm.
something that other people may not know how to do. All right. So yes, now the professional success stories.
That's awesome, by the
So
way. I like that one.
yeah, it's interesting because to me, I've always viewed technology as a tool, and in the end, like you're either trying to do it to do something that matters, or you're just trying to learn. So it was kind of a key foundation of like how do things work, and in some ways that gets me in trouble because I'm always trying to figure out how something works necessarily than solving the problem because sometimes those don't necessarily go together.
You are an
But
engineer, by the way.
yes. So not necessarily the best tech support person, but occasionally someone like, give me a research paper and like, let's go read. So really the biggest success and the biggest like hallmark for me is it was a project and I may actually get the marketing name wrong, but for us, it was called AT&T Lightspeed. And it was a culmination, the company was Two Wire, and it was a culmination of efforts of literally changing how streaming video worked. And the reason why that was such a success is all I can let me just paint the picture for you. You're going into this meeting, and this is super important to AT&T because they're literally going to compete with Comcast, and they're going against a standard cable distribution, and they want this to work. So they partner with a few companies, and we go into these project meetings. There's like 200 people on the call. when your introductions for a call take like 30 to 40 minutes to just kind of go through the whole thing, and then they get to two wire and it's like, hi, my name's Charles. And then the other guy's like, hi, my name's Chris. Yeah. And so like, we sit there and like there's like two of us. And it's only so needless to say, what was successful about that one was you stood not up to, but you stood with. You partnered successfully with AT&T, Alcatel, Microsoft, Two Wire, and that collection of entities that
Wow.
basically delivered. And that was it was one of those very odd occurrences because it really shaped me. And sorry, the reason why I say this is because this was in my early 20s. So this is my first
Mm.
job. So I left grad school. And as we all know, school and profession are exactly the same. Like school is exactly the same as your professional career. That was sarcastic.
Yeah.
Uh, and so this exposure of this project of building up to it, it took like 4 or 5 years to kind of get to, but there was a whole bunch of deliveries along the way. And what it really just indicated was that, as long as you knew what you were trying to deliver and you knew what you're trying to get at, you could really accomplish a lot of things. And the most interesting thing that we found was Microsoft was clearly owned the technology. They owned the back end and they owned the front end. So they owned the screen area. But the oddity for us, and again, there's something wrong with Microsoft, they didn't do networking. So they didn't really understand the pipe between. So when a lot of the problems would show up, it was not the front end, it was not the back end, because they're pretty self-contained. They knew how to test those, but the system integration, how does the whole thing work? And we basically ended up being the last mile. So
Huh.
many of the conversations were like, well, this doesn't work. Why? And it really exposed you to debugging large systems that you couldn't really observe yourself, but you had to speculate on what was going to happen. And also having conversations with people that were a heck of a lot smarter than you, but also weren't necessarily aware of all the details. And so just trying to help them through, hey, here's what's going on that. And yeah, so that makes sense. It was very formative for me because it was also one of those very weird situations where I literally think there was 70 to 80 project managers on one call
Wow.
split between Alcatel, Microsoft, AT&T. And people, oh my God, that must have been, it was so important to AT&T. They just didn't want it to fail. And so
Yeah.
it's hard to get mad at them, but it also created this environment that was not necessarily the most conducive to being kind of an engineer of like, hey, I want to go try
Yeah.
this,
Yeah. 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 I love that story because it's a little bit of a David and Goliath story too, right?
Mhm.
But I think it's important for product people, I think the ones that have been around that understand that there can be all of these enormous players that are doing something, but if you find the hole, the
Mhm.
place where people just haven't filled it for whatever reason, um, you've got something that's really valuable that can be success. And it sounds like that's what you guys did in that situation.
Yeah, exactly. And it also got you used to really dealing with enterprise architectures and a lot of requirements and just getting through that cycle. And I think the reason why it matters so much to us is, Two Wire had been going through growth for this period. And so this was probably realistically, this was probably like the biggest enterprise project that we had really been involved in. So we've been doing residential gateways for a long time. And I know this may sound ironic to some people who aren't our age, but networking in your house was not a thing at the time.
That's right.
And so
Mhm.
we were trying to figure it out. Like, how do you make the network in? And I remember talking to some friends, and he's like, well, I have networking in my house. I just went and got an x86 from Fry's, and I went and installed BSD, and I set up my dial-up modem, and then I just redistributed my network in the house. And I kind of looked at him like, yeah, I'm going to write up those instructions and give them to my mom.
Yeah,
I mean, that
exactly right. Exactly. That's what I was thinking. Yeah, she can do that too.
and so it was also the that exposure of going from I knew technically how so much stuff worked, but I didn't know how to make a product to
Yeah.
wrap it up so that people could actually use it. So two where I've been going through that, and the the only thing I can say that was funny about that particular genre is there's this like UPS commercial. I don't know if you ever saw it, but like this UPS commercial where it's the too many orders or
Oh, yeah,
something, and
yeah.
it's like
Uh-huh.
yeah, like they're staring at the screen and like, oh, we just went live, and it's like zero, da 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 da. So basically, Two Wire had literally landed AT&T as a partner, and we had worked up to that. And we'd gone through like the CLEC days, the ILEC days, just trying to get through everything else. And then AT&T became a partner. And it was literally that setup of 5,000 a month. And I probably have the numbers wrong. It was like 5,000 units a month up to like almost like 5,000 a day.
Mm,
And when we were going through that phase of scale out and scale up to match that, it was hell because
mm,
every little thing became a big thing. There was nothing simple because 1% failures on a million units in the field meant someone's always failing. And so trying to work through all those problems there. That then gave AT&T the confidence that we could get into Lightspeed. And so before just kind of being the edge device that was like the network and effectively a modem to them, they actually started integrating us into their network policy.
mm,
And that was what really changed for us was once you built up the confidence, and really it is a partnership, you have to build up the fact that they trust you to enforce part of their network policy there. And the only thing that I find interesting about today is I actually still have, it's Eris now, but I still have effectively similar software. Some of it, I think, actually still the stuff we wrote
ah,
from 20 odd years ago sitting in
that's
my
cool.
house. Yeah,
That
because
is so cool.
I have AT&T networking to my house still. And so I still have, I think I looked, I think I actually still think there's some of our code running on that gateway. I don't know how much is left because I haven't been there for quite some time, but it's still kind of interesting. So yes, that's the success story.
Yeah. No, that's a great
Hopefully
one.
I
It has
explained.
a lot of elements to learn from there. That's super cool. Um, so now flip it. Tell us about your greatest failure. And the juicier and the bloodier, the better, because that's what we really learn from too, right?
Yeah. So this is interesting because given the context of the accelerating product development, you can always debate like that. So speed. Um, yeah, Xbox. They don't actually, and I don't have this thing with blocks companies that just
I was about to
strictly,
ask.
yeah, it has nothing to do with it. That was strictly just circumstantial and a coincidence. But Exobox was a distributed storage company, and at Carnegie Mellon, I had done research at the Parallel Data Lab, and so storage is still kind of one of those first really complex problems because it's a long stack and there's a lot of moving parts when you start going through it, through persistence layers, through presentation layers, through everything else. So as a study, I really enjoyed my graduate school time looking at storage systems and a lot of those problem sets. But then the market was, well, let's go do home networking at Two Wire. And so then Exobox came along and I kind of went back to my storage roots. So part of that context is it was something I was really looking forward to and enjoying because I wanted to get back to those problems because I kind of felt a little adrift because networking is challenging, but it wasn't the end all be all. So Exobox was something I really actually wanted to work because it was very hard. Uh, so now then the base of the challenge. We're building a long stack and it's complicated because it's not like, oh, take a packet in, stick it on a queue, get a packet out. You're literally trying to say like, okay, let's get a file system protocol, let's get multi-head and like actually get through all of the protocol work and then go out to a distributed key store and then basically save everything else. So, and we were also trying to be novel because instead of building on traditional block storage, what we were actually trying to build on was key value storage. And there was some research at the time that was only like a year or so old that was trying to modernize some of that distribution, and we were trying to take advantage of it to be kind of the first to market and build it out in a new way. So the features were novel, but the stack wasn't known. So it wasn't like a traditional file system where you kind of knew what the performance characteristics were and you kind of knew what everything was. You were trying to layer it in. Basically, we got it working. So standard problem. You get it functional, but you haven't really characterized it.
Mhm.
And we had major performance problems because we just had bottlenecks everywhere. We had tons of issues just trying to isolate them. And we got it to the point where we thought the performance was good enough. And basically, the story is we got to where we thought we were good enough
Uh,
and we released it. So we go in and we now have this SSD product and we now have all the IOPS. And why this one strikes me as so much is that it was an effort. Like we put so much effort in this. We get the unit back, we pop the case, we all sign it, and then we ship it out to the first customer. and it did not go well.
Uh-huh.
Um, they had problems within 24 hours, and
Okay.
we were trying to log in and basically try to figure out what was going on. And it's the standard stuff. They were using it in a way that we
Yep.
had
You
not
had
even
not
thought of.
tested for, you hadn't tested for and whatever. Yeah. Yeah.
And so then it's the scramble drill of everything else. And then they started trying to fix it themselves. So and they were like outpacing us on change rates. And so they
Oh,
were
wow.
modifying the system. Well, they were modifying the system because they wanted it to work, and people were so invested in trying to make this work that I think discipline and control kind of went out the window in
Yeah.
more of hope and
Yeah.
optimism.
Yeah.
And so I'll jump to one of the lessons I took with this. Optimism can not be a good thing. Optimism can be a
Yeah.
very, very bad thing, particularly if you're trying to triage and solve problems.
Yep.
Sometimes a little pessimism and a little bit of balance there is not the worst thing. So long into the story is they returned the units. I think it was like I might have it wrong, but it was like I think it was like 3 weeks or 5 weeks in, and we had just been working around the clock trying to get everything to work. And that struck me not because I still don't think anyone really did anything wrong. I just
Hmm.
think that we had too many unknowns. And so the known knowns, I think we took care of. I
Hmm.
really do think we tried to take care of the known knowns, and the known unknowns. I think that we mitigated. What happened was really the unknown unknowns.
Unknowns.
Basically,
Yeah.
yeah, they basically creeped in and slaughtered us. And so we
Hmm.
took the unit back. Then I just installed it in the lab, and we just started trying to use it so that we could just use it more and more and more, and get set up there. But that really marked the company because it was a hit to everyone's emotions, to everyone's else. And
Mm.
I think the irony
Yeah.
is that, and I think the irony is as you work through product and everything else, everyone says like, engineers aren't emotional or people aren't emotional. I mean, when
Hmm.
you're grinding, 60 to 80 to 90, and you're just trying to get on issue after issue, a lot of what carries you through that is emotion.
Hmm.
And if you start not looking forward to solving that problem or not looking forward to solving that thing, it hurts. And that failure market. And I learned from that one of just like, you can still try and do everything right, but it can still turn out wrong. And you can basically, you know, go back into your shell and say, hey, I'm going to be risk averse. I'm not going to do this. I just was basically like, the next time, just try to make sure you understand the problem better. The next time, try to make sure you get a pilot program better. Just next time, try to make sure that
Yep.
you get a grace period better. Next time, try to make sure you do a side by side. Don't sell it as the replacement product. Sell it as like a
Yep.
side by side. See if you can do a mirror. Like you things you could do.
Yeah.
But it's also the interesting thing again for context for product. There was things that were outside of our control, and
Yep.
I don't blame product, but we didn't really know how they were going to use it. So that partnership with the customer, you learn that's pretty important because
Yeah.
if the customer comes back and tells you, "Hey, we're going to use it this way," and they do it something completely different,
Yep.
it's still kind of your problem,
Yep.
but at least you can talk to the customer about the use of what's going on.
Well, and
So
it's an interesting thing because a lot of times customers think that they're using, so we get into this a lot when we're implementing engineering tools for people, right?
yeah,
Applications or whatever. They say, this is how we're using it. These are our requirements. This is our process. And then you start doing it and you realize that's not it at all. That's just what they think. I mean, they're not lying to you. They're just telling you what they think. But there's so many complexities involved in human nature, like the human use, right? Or a
hmm
company use of a product. And that's why I love the story because there's so much in there that there's so many lessons that you guys learned and even lessons about culture and morale and things, which people won't talk about as much, which I think are really, really important. But also, there's so much of a fail fast, kind of mentality these days, which goes along with accelerating your product life cycle, but you can go way too far with that. And as a little bit of what happened to you guys, right, is that you just went too fast.
well,
And that was
yeah.
a situation where you shouldn't have gone quite as fast,
Well,
maybe.
and the irony, well, oh no, spot on. Like, and that's the beauty of the hindsight is, but
Mm.
when you were in it,
Yep.
you weren't going fast enough. And
Yep.
so there was a constant like, we need to go faster, we need to go faster. And then by the
Yep.
time you finally got out of it and you really got a chance to just catch your breath,
Yeah.
you look back and go like, yeah, that was
Yeah.
not a good idea.
Yeah.
um,
Were you guys, I'm curious, were you guys trying to beat somebody else to market? Was that there? Or was it just sort of anxiety of we're going to be too late? Or were you running out of money? What was the push?
um, you know, actually, so here's the struggle for me is I was so focused on the engineering. I was like, I mean, I was a
Yeah.
1000% just, I got to make this system work. I got to make it. My recollection, which is why I want to be careful. I don't know if I
Yeah.
got it right, but my
Yeah.
recollection
Yeah.
is we were between funding rounds, and so we were
Oh,
basically trying to show a milestone and show incoming revenue to transition into the next
yep.
series.
Yep.
And that was kind of where we were at, which is that we needed to get past the prototype, the burn stage, and start showing some of the revenue stage, not profitability, just revenue. Like we need to
Yeah.
start showing customers revenue so we can start scaling up the sales cycle and everything else. And so I believe that the timing that's what worked out, and
Yeah.
that's what I recall. But again, I don't want to speak for what was going on for other people in
Right.
the company because my job was an engineer. My job was
Yep.
to basically make it work. And I probably should have done a better job myself, but I think there's just a lot of factors, and it's one of those interesting. Even because you just said the word fail fast, and pet peeve of mine. Okay, fail fast. Okay, yay, we failed.
Yeah.
Okay, now what?
I know.
Yeah,
Yeah.
and it's like fail fast and then adapt. And it's like everyone.
Yes.
There's so many times that I keep looking at people like you have to learn from the failure, and that's something. Again, like I said, the statements are always easy to make, but
Yes.
when you're in the trench,
Yep.
your blinders are up.
Yep.
You're trying to get through stuff.
Yep.
Um, and like I said, the biggest thing about that advice that I could always tell people is sometimes try to keep some neutral parties in your company that are not in the trench with you
Hmm.
and use them as a sounding board and try to keep them to the best you can on the outside as a referee or a fair arbiter, just to
Yep.
make sure that they see what's going on. Because as engineers, if it's working, I'm not looking at it. And that's one of the biggest ironies for people who are probably, Charles, why didn't you use this product? Because that part's not broken. So this part's broken. This is what I'm working on. And so engineers have a tendency, and it's a statement, as I said, and that we need to fix something. And so we're looking for something. And so we're obviously trying to break it down or isolate it or something else, which means do we use it the way the customers do? Maybe some do, but most don't because we're trying to
Hmm.
just go in and do it. Which means that that outside arbiter of if you're trying to go
Yep.
fast and you're trying to look at the product, you often need help as an engineer of someone that
Yes.
is actually looking at the product. As smart as as so many engineers that I've worked for, we just don't look at the product because we are
Yep.
trying to look at the problems and look at
Yep.
those setups. But that's what that failure told me is you have to
And I
work
would even
hard.
argue that for most, I mean, engineers typically are analytical people, and not everybody in this world, including the people who are going to use the products, even if they're technically oriented, are analytical people, and people's minds work differently. And especially after having kids, I can just attest to this because you explain something to them and they just look at you blankly and you think, I just explained that well. It's the same kind of concept, right? You can't know how somebody's going to see the software or the product or what have you and interact with it because they are just different, unique people. So, to your point, if you have other kinds of people that are looking at it with you, they're going to tell you, Charles, that's not how somebody's going to see that. They're not going to use it that way. They're going to use it this way instead. And if you don't have that around, like you said, you probably won't even think of it. You probably won't even consider it.
Yeah, oh no. And but it's also like sometimes you just want to know what your role is. And I always try to caution people, what's the analogy? The color of the bike shed. You're building the nuclear reactor and everyone has an opinion about the color of the bike shed because everyone wants to argue about the bike shed attached to the nuclear reactor, but the nuclear reactor is a technical thing. So we know how to build that, but color of the bike shed. We really and I think the term is bike shedding, if you ever see people doing that. But that was the thing is technology is a part of the how and what it does. That's always the engineering domain. And you really want to make sure you're confident in expressing what you've built and everything else. But one of those things that I've always done is I kind of take a step back. And yes, I can have an opinion about the behavioral or the look or the interaction, the human user interaction, or depending upon what the product is. But I often will just take a step back from that because that's I think that's important to just let other people, use it. and then help to steer for what they want to come out of it. But I think there's also like that friction point is if everyone has opinion about everything, my concern always when I deal with a lot of groups, everyone starts looking at the same thing. And
Mm.
you start, and one of the benefits of a group is many eyes. But if all the eyes are looking at one thing, you'll miss some of the problems
Yep.
that some of those eyes may have seen. And maybe they're not the most important problem, but you'll just flat out miss them, at which point, they come up as surprise. This customer just hit this, and you're a little confused by what they actually saw. So that may have been a little random, but like I said, it's just sometimes I think
Yep.
you want to basically take advantage of the collection of people,
Yep.
even though individual talent may lay a lot of the bricks and build a lot of your foundation. It's the actual collection in the group of people that, as you go
Yep.
through phases, you want everyone to contribute in the phase that they're looking at. And back to your comment about acceleration, yes, you could ship the product as soon as it compiles on my laptop. Let's just push it out to the field. If you don't take advantage of a couple of the people around you, you're always going to miss out on just some feedback or just something
Hmm.
else. And listening to people costs very little. Not paying attention to what they're actually telling you can end up costing you a lot more than just a
Yep.
little bit of effort on that conversation.
Yeah.
So
Yeah. As a leader of a company, I believe in this so strongly. It's just been proven to me over and over. You just start to get some different minds in a room or on a call or what have you, working on something, get all these different perspectives and kind of a new synergy. You can't even really describe it. There's like something new, better, higher comes out of that than if you
mhm,
even just had one or two. But I would love to pull you over to your current, because I really want to take an opportunity to talk about your current
sure.
situation with RedoxBlox. I love the name, by the way.
Mhm,
Um, and I know you guys are you're pre-market or you're pre-revenue, but first of all, and I'm just a huge believer in the whole alternative energy and decarbonization and carbon capture. And I have it's just one of my hobbies to sort of track this market, and we have some clients in your space too, and I love it. So first of all, just tell me about your company, the product that it's developing. Just give
mhm.
us an overview of the problem you guys are solving, and also what makes you different. Both those things.
Sure. So it is interesting. There's a position to always say like, hey, I want to be good for the planet, and I want to have a stake, and I want to be green, and I want to do it. I actually agree, and I've talked to our CEO, and I'm actually, we've have very similar vision. We want to make a better product than what is already out there. And so I think that's still one of the things that we always want to make sure the underpinning is the product needs to be good. It doesn't need to be green. It needs to be better than the
Right.
alternative. And so one of the quickest ways to describe this is, we start looking at just distribution of oil and gas, and it's a commodity, and the burn rate is all on demand. So if you actually just go to an infrastructure where you have a renewable energy source and you're doing electrification of that across the line in green tech, you already should be cheaper. Now, outside of the initial investment, but you should be able to make that money back on the initial investment because you're just not shipping fuel around and you're not doing logistics and transport. So when we were looking at this problem, and when the founders and the technologies, I obviously was not. I joined a bit later to help with the productization and commercialization elements of it. But a lot of the research, what's going on here is you don't have to burn to make heat. You can actually, it's an energy transfer. So you can actually use electricity, and you could heat a material by transferring electricity and then heating a material. And that's fundamentally what you're looking at now is you don't actually have to burn methane. You don't have to burn CH4, or some construct of CH4 and make CO2 and make water, and basically burn everything to make your heat and make your application. You can literally apply energy and heat something up and then let that heat dissipate by basically sending air through it and feeding into it. So the concept is, let's go out and make a product that can basically be the equivalent of an electrical battery, but be like a thermal battery. So
Hmm.
we can charge you at an appropriate time and an appropriate level, which means that we could use like solar or other renewable energy sources to basically charge you up. And then we could dissipate the thermal energy at night or whenever you need to on demand. And I think the puzzling part is everyone's like, oh, well, what does that really mean? If people are working in manufacturing or in operations, industrial heating application, I think it's like a $2 trillion market. I mean,
Mm,
every type of factory, like just to heat, the factory itself, you need
right.
heat. A lot of the processes, you need to boil something, so you need heat in all the applications. And there was a lot of stuff about green, like, oh, but doesn't that just mean you need to make everything electric? It's like, no, you just need to make sure that the energy where it comes from is phasing more of a renewable source, an electrification for the generation side of it. But then the consumption side of it, you don't really have to change your process and you don't have to change your plant to consume heat. And just one of the simplest cases, boiling water.
Mm,
If you look at industrial boilers, that's a massive market of just the ability to
huh.
boil water to then use in an industry. That's a lot of use cases. There's
Yep.
more to
Yep.
that than you would think. Commercial buildings, high rises, using boilers and everything else for those things. So there's a lot of application. So that's the market. And then, effectively what we're after is uh, this becomes now just a renewable source to where over time, you're literally just able to charge and discharge. And this kind of, it's a toaster. It's
Yeah.
basically you're literally, it's just going to sit in the corner and it's going to do everything that you ask of it. And that's why it's going to be a good product is because when it
Yep.
works, you don't even know it's there. And
Yep.
when it doesn't work, because it's now going to be modernized, we can actually give like hopefully, well, we will. We'll give like more diagnostics and help the troubleshooting efforts for what's there. But that's the overview. Hopefully
Sure.
that gave you some
No, it
context.
does. So let me just to rephrase a little bit so that I know that I get it,
Mhm.
and so that our audience gets it too. I mean, obviously, battery is one of the proverbial ways to store renewable energy at this point in time. So instead of just storing the renewable energy in a battery, you guys know that you're going to have to distribute heat, and so you're choosing to store it in a thermal and battery or just a thermal type of technology so you can then dissipate and distribute the heat from that into the factory. Is that about it
Yeah.
or did I miss something? Okay.
No, no, no. If I had to give you the analogy for your house, assume like you turned on your oven and you cook
Hmm.
your oven to like 400 degrees.
Hmm.
And then all of a sudden at night, and so you left your oven, it's all insulated. So that 400 degrees is staying in your oven. And then at night you get cold and you just open the door to your
Open the
oven.
door. Yep.
And then that heat comes out and then that
Yep.
helps heat your house for it. So
Yep.
as a very rough analogy, that's kind of what I would say, so that it's relatable
Yep.
for
Yep.
that.
To people
Li-
in their homes, right?
a little more complex, but
Sure.
hopefully,
Yeah.
yeah,
Yeah.
something simple.
But and it's interesting because I think a lot of people aren't familiar with the industrial factory space, right? So aren't
Mhm.
actually understanding of what's required there. Okay, so tell me how your got without getting into, any
Mhm.
details you can't, but how is your IP different? Then is there anyone else out there that's trying to store in that way in industrial space, or is this brand new?
So RIP is fundamentally different in that what without being a market expert, but I say that most of what people are attempting to do is they're trying to go to a thing called e-boilers, which
Hmm.
is effectively just take electricity and heat the water there
Right.
directly,
So
or
using
the e
electricity. Yeah.
but directly to the water, okay, or going to an e furnace or going to an e whatever. And albeit that's fine, but the challenge there is all of those applications, typically the efficiency or whatever else you're trying to do, and they also become very point, like that's all it does. And now
Yeah.
you're trying to, so for us, and you still have to do it on demand. So for us, one of the biggest things that we have is you can charge and discharge. It is a battery. So that's the reason why the battery is so important is you can choose when to charge it and you can be charging it while you use it, or you can also just be charging it at a better time for you and then discharging it later. And that thermal storage effectively allows you now to schedule your process and schedule your demand so that you can control your costs a little bit better. So there is a very important element of being a battery in addition instead of just a heat source. Because if you just took electricity, you could electrify almost any appliance. But
Sure.
but then the problem is you have to turn it on when you're there. And if you're on grid demand or you've got like contracts with electric companies or you're trying to like heat your factory, the electric companies may ask you like, hey, I want you to, consume at this rate because now my grid load, I can basically offshoot it. Or, hey, here's when the renewables are at peak. I want you to charge up during this phase and I want you to discharge at night because then the renewables, we're running the grid off of a different element. So, and as far as this material, the material hasn't been used before. So we're
Okay.
going through the R&D efforts and the operations elements for basically commercialization of this technology. To my knowledge, and again, I don't want to speak for the world, but to my knowledge, no, this doesn't exist anywhere else. So when we looked, and I can say Google search did not pop up and match. So from the access of information I have to, but you never know, in like some deep dark corner of some
Sure.
super secret special sauce, you
Sure.
never know.
Yeah.
Someone may be doing this. But the to our understanding, no, it's a new application, it's a new material. There's literally no carbonization of it. Like there's no burn, there's no methane, there's no natural gas. I mean, there's just nothing to it. And effectively, our product outputs oxygen. So
Hmm.
one of the biggest things about it is like it is 100% green and it is safe. Like
Yeah.
there's literally you're in an industrial application, you're dealing with really high temp. So like I want to be careful. It is industrial equipment. So yes, there is
Sure. Sure.
inherent
Sure. Yeah. Yeah.
industrial, but from a environmental point of view, when you look at it's what you want. And so the folks that are working on the material science, they're a blast because they are literally trying to formulate everything they can to make this as effective as possible as a heat storage element.
Yep.
And they are working as hard as they possibly can to get that through it. So, it was a great opportunity. It was a team that we felt when my group and I formed them and we joined up. It was a team that was really worth helping because they were
Yeah.
doing some um,
Yep.
very hard work of trying to go through material science. And for people that are not familiar with material
Mhm.
science, it is not trivial.
Yep.
It is electron microscopes on steroids, trying to figure out structures and formation, chemical formulations, processes for heat, pressure, everything else that you want to do for it. And so when we came in and saw that, and that was actually handled very well, it made our part a lot easier because we're there for a lot of the Internet of Things style stuff where we're trying to come in, make sure we can build the control systems, make sure that we can build the software product, and kind of breathe life into
Sure.
the product.
Inanimate object. Yeah.
Mhm.
Right. Right. Right.
Yeah,
Yeah.
yeah.
That was my next question for you, is to talk about, which you started to, but just tell us a little bit more about the interaction then between the software team and the quote unquote hardware, but really materials team at this point. Like what, um, I think people are always interested in how those engineering teams interact and how you guys are working together, and what parts of it do you work on by yourselves? When do you guys do more of a systems check? Like just all of that product development related um, stuff.
Sure. I guess the thing is we can always throw out the term agile and that cures the world. Once we actually mention agile, everything's set, everything's perfect, nothing ever goes wrong.
Yeah, right.
So we're agile.
Okay.
So that's not really the case.
No.
Needless to say, we do subdivide into specialties.
Mhm.
As far as the organization of the teams go, we do a monthly. It doesn't matter your title. Come in and do a show of the work.
Hmm.
And it's important to us because even if I'm working on cloud software, we still want to see what the material science work is. And
Hmm.
work for us is paramount because what's the one thing the most precious commodity in any startup or any company is time. You cannot get time back. There's a lot of other things you can do, but you can't get time back. So work is the effort and the time that you spend. And so when we talk about showing that work, it means we want people to show where they're spending their time and what
Mhm.
they're doing and teach the rest of us about what's going on, what are they facing, and everything else. So that's the free for all. That's just basically the topics range everything from material science to we're doing cloud deployments and discussing everything, and all the engineers listen to it. It may not be your field, but you can always pick something else up. And the goal is to always spawn conversations. Now, outside of that, we just have traditional systems engineering meetings for the generic structure. The product side is more the system side. And then the cloud side, we just call it the cloud side because we
Mhm.
haven't come up with a better name yet. Um, and then the systems interfaces, it's pretty much what you say. There's the material science side of it, the mechanical side of it, the hardware side of it, the software side of it. And that all kind of umbrellas up into a systems meeting, and you pretty much work through that to get through the actual product parts. That's a it's a meeting that we've all been there. I mean, we've all gone there before. It's like a small group meeting, try to get a couple of the leads together, and then you just discuss the interfaces and go through
Mhm.
there. Ultimately, yes, you're correct. The material and mechanical sides are more or less the consumers of the hardware and the software control loop side. So
Mhm.
they're driving the requirements for the internal product fundamentally. And we're basically trying to ensure that we're building out power electronics or whatever else, venue, heater control, venting control, or motor control, or some form of control for an embedded system, and we're trying to encode that then into software so that we can do the software control loops for safety, for
Right.
compliance, for everything else. And
Right.
so yeah, I mean, like I said, the this is one of those interesting things where alluding back to what we talked about, you know, the product is new. It's definitely a new technology. Like it's hard to well, just haven't found anything that's exactly like it.
Mm.
Um, but the problems they're not that new.
Hmm.
There's definitely
Yeah.
some areas like, oh, I need to go, bring up a microprocessor. Oh, I need to go, do a firmware update to the microprocessor. Oh, I need to make a network
Yeah.
connection to the cloud. Oh, I need to
Yeah.
publish data to. So, there's a lot of things that we want to, as we joke about, you should do the things that you know how to do and they should
Yeah.
get done so that you can then focus on the things that are a little bit of a larger concern.
Yeah. So is a fair amount just of those things that you just said, did your experience at ChargePoint then is some of that software development experience apply here, I'm sure, in certain ways and
Oh, the beauty for me is it's not one company. It's a life.
mm,
We uh, I can even joke about this one. Like, sorry, this will be a little segue, and I'm not even sure if you'll edit this in. But when you look at experience, like you never know where it's going to come from. So
yeah.
I grew up in New Mexico. I grew up in Las Cruces, and fundamentally, we're an agriculture, more rural
Yep.
setup. So when people talk about like experience, like how to solve things, we didn't have a lot of access to tons of ability. So you're trying to fix things, duct tape and baling wire.
Yeah.
You work on farms, you work with a lot of people. So you become very what's the minimum thing I need to get this done?
Yep.
That experience carries even all the way up to a lot of this stuff. So it wasn't like just ChargePoint. Now, ChargePoint from green space, yes, it informs the market. Yes, it informs electrification. It informs compliance, a lot of the governance. But that whole history of experience
Mm,
is something that you draw on. And
yep.
that's something that you kind of carry forward all the way into this because not a lot of people have ever worked on a diesel generator, but I have. And when I was in undergrad at New Mexico State University, I actually went double E. I was an electrical engineer. New Mexico State University has a power engineering program.
Yeah.
They actually, and they're one of the few companies. Who would have thought that would come back into my life? Like
Yeah.
actually
Yeah.
knowing like how transformers work, what three-phase power looks like, what RMS,
Yep.
those things. And so there's so many elements that come into that. So that'll be an interesting edit for you. I'm
No,
not
I
sure
love
like
that.
the
No,
yeah,
no, no,
because
I love that. No, and my response to that is I completely understand what you're saying. And it's one of those things that I think after you have at least a few years under your belt, you start to see how every person is unique in that way, right? That they bring this. not just, oh, I learned this in school or I had this experience at my last job. It's like it's just sort of in their whole identity. Like in
Yeah.
your case, it's where you grew up, the fact that you worked on diesel generators, which we have one outside, by the way. So if you ever want to come over and help, no, my husband actually can work on it too. But just all of those things are part of what you bring,
Mhm.
you or anyone brings to, let's call it a job, but it's a job where you're trying to serve other people. You're trying to create something that's going to serve society and serve the community and be valuable, right? So I love what you just said. I think that's so true. Yeah,
Well,
completely.
and I think the only reason why it's important to discuss for people is, we often get caught in that here's how you do something. Oh, I did it at
Hmm.
this company. Oh, I did it this way
Hmm.
before.
Yep.
And probably the one thing I'd like to convey on this thing is every group is different. It's composed of individuals. Learn about the people that you work with because their past makes them unique, which makes your group unique, which means that how something was done before in a prior composition of people may not actually be the right way to do it
Yep.
this time.
Yep.
And so if and this goes back to how do you go fast? Well, you go by fast by using your strengths and your uniqueness and covering for your weakness.
Yep.
I am not a material science person. So, if we didn't have material science people, I would not be the person you want in the lab trying to figure that out because, yes, I could probably get there with some searches and some education, but that's going to slow us down by 3, 4, 5 years, instead of being able to get something done in 2 months. And one of the things that I really always appreciate about these companies and especially this team and this group of individuals is the recognition that everyone is bringing something different to the table.
Yep.
And in some ways, we probably don't say it enough, but valuing the contribution of everyone, the effort and the time they put
Mm.
in. Yes, we want the monetary. Yes, we want the pay, but just like if you can engage and just talk to people about what they're doing on that stuff, you'll always find that just even from your own self, you learn something and you actually get a little bit better at what you're doing. So, RedoxBlox for me is just it also goes into some people could call it a personality issue. I don't really like repeating myself. So I don't really like when I went from TOR, I went back to storage. So yes, there's some overlap. And then from storage, I went to EV space. And then from EV space, I'm going to industrial. I have never been very good at being a specialist. I'm just not good at it. I don't like find an area and then just refine and become like the expert of one thing. So I'm not an expert. What I have always found is I like problems
Hmm.
and I like learning. And I definitely like being around other people that like to learn and like to solve problems. But it's one of those interesting things. If you just go from place to place where it's kind of the same problems and you solve it again and again and again, then there's really, for me, not much learning there. So it's
Yep.
kind of like I keep trying to look at that balance. Um, and then back to our discussion. If you're learning and you're solving problems and you're enjoying it, the effort and time that you spend into it, you're willing to spend the appropriate amount of time to actually go fast and accelerate. So my stance on most of that thing is I just don't want to waste people's time and effort. And I'm almost like I'd almost say paranoid about it. Like I really
Hmm.
feel it really gets to me if I see people working so hard
Mm.
and oh, can you go do that again? Oh, can you go do that again? And that tears me up on the inside because like I just don't like seeing that. So for me, it's not actually about accelerating. It's about getting from here to there with and a lot of people call it lean. I don't know if you ever heard of lean
Yep.
development.
Oh,
Okay.
sure. Yeah.
Yeah, yeah. Well, and if the audience hasn't, look up lean development.
Yep.
I make fun of agile. I don't make fun of lean.
Yeah.
So lean for me is just that's where I always want to be. I want to
Yep.
be lean and mean, and just really work on eliminating waste. And that can be a loaded term for a lot of people. It can be
Yeah.
a
Yeah.
trigger word, but it's not about that. It's about you're getting from point A to point B with minimal effort and
Yes.
maximum outcome. And
Yep.
so for me, that's kind of circling back to this conversation about like why RedoxBlox, why everything else is I like going through startups because we're starting from something that is risky. It's not proven. And you're not a fast follower. You're not trying to chase someone else. You're trying to pave some ground, break trail, go up that hill, pulling the dogs in the sled behind you. You're out there kind of by yourself. And it's sometimes a scary place.
Yep,
Um,
yep.
but you just keep trying to push your head, and all you're trying to do is make progress. If it's a half step, 3 steps, 2 steps, you just don't want to go backwards. And that part of like accelerating product and everything else is if you can get that mentality into what you're
Hmm.
doing, you really will actually feel, I think, more fulfilled and more accomplished. So at the end of the day, through successes and failures, you can look back on it and just say like, I actually did my part. Like, I carried that water. I did the work that I needed to, and I know the work and the time, the effort that I put into it. And that's what I got out of it. But most importantly, because I solved these problems and I learned this, my tool chest for the next gig, for
Yeah,
the next effort, well, I got a little bigger tool chest back here that I can take into the next thing
that's
for
right.
that. So yeah. So sorry, that was a little bit of the brain train
No, no, no.
going down a little
And
detour.
no, no, no. And I'm glad you said that because it's actually really, really important. When people hear the word accelerate, they think stick your foot on the gas pedal and go faster, right?
Mm-hmm.
That's not necessarily the best acceleration in engineering and product development. I believe what you just said is that it's really about being lean, right? So really figuring out how can I get from point A to point B, release, let's just say product release of this particular product or version of it. How can I get there as quickly as possible, right? Through better efficiency, through better operations, through a smarter way of doing this or a more intelligent way of doing that, of getting the group together and working or collaborating in a different way. Those to me are they're like the levers that you can pull, you know, to
Mm-hmm.
actually make that happen. And it's not the same story for every company. For every single company, it's a little bit different. And every single team, I think it's a little bit different.
Oh, exactly. And I think it's even one of those statements that you really have to reflect on a little bit. And every single time you should always try to reflect when you can. Accelerating to a delivery. Okay, but what after that delivery? Because
Yeah.
acceleration actually should be continuous improvement and continuous
Yes. Yes.
learning. And because now you may not be able to accelerate this product because it just takes this much time to do this.
Yep.
But now you can accelerate the customer response. You can accelerate the
Yep.
scale out. You can accelerate the manufacturing. And so if you're not wasting time, chasing rabbits,
Right.
then you can literally spend your time. And that's what I also think what accelerating is. Accelerating doesn't just mean, I'm in a car. Accelerating could be I'm in a fleet of cars. And
Yes. Right.
and so if I do something here, those my team members who are
Yeah.
dealing with something else, they may actually be able to get up and get past. And so
Yeah.
acceleration is also, I think the challenge is there's individual, which you should think about yourself, but in the end, it's still team. And
Yeah.
so if you all make it there, but also don't forget that very rarely is it a destination and a light switch. I'm done.
Yep.
It's always the okay, we got to here.
Yep.
What comes next? And that goes back to that story like of AT&T and everything else. Like we got to the point where we like closed the contract, but then the scale up from there was miserable. It was like
Oh,
six
yeah.
months. Well, because you got to where you need to, but you have to still be prepared to keep going. And that's the thing you have to balance, which is, make certain that you're hitting what you said you were going to do.
Yep.
And that's super important. But then realize there is something that's going to come in behind it. And when
Yep.
something comes in behind it, you still got to be present. You still got to be able, you still got to be able to get there. And you still have to be able to do the work. And that's
Yep.
ultimately the one thing that's so important about product delivery is we say this in a general term because most of the products we work on are complex enough. They're not like I built this one product and I'm done. I don't have to do anything else.
Right. Right.
I'm not sure what that product is, but I have
I
definitely
don't know.
not
I
worked
was
on
going to say, I don't think I've ever
one.
met that product myself, but go ahead.
Yeah, exactly. So every product I've ever worked on, there's always been bugs or something else that comes after that. So like I said, I would always encourage people to have conversations about what does this mean, and what are we doing this delivery? What does it mean? Because I've also been on the fence where I have worked weekends, worked some late nights, been told the date, and I'm sure this has never happened to anyone else, where, we show up on that date. Okay, I'm so tired. Here it is. Who's using this? Where do they go? Why is no one here to pick this up? What's going on here? Like, what happened? What? And so even acceleration means that it's the systemic point of view. And I guess that's one of the things that I'm a systems person in general. I look at the whole thing, which means
Hmm.
that if one piece goes really, really fast, that's fine. But for product
Yep.
delivery, everything, you still have to land and get everything there together
Yep.
all at the same time. Even,
Yep.
even stuff like shipping containers. Like,
Hmm.
never underestimate the pain that people like operations or logistics go through, where you can build the full product, but we don't have the shipping containers and stuff set up to actually ship it from the factory. You can hit all of these things between there. So just always try to appreciate the work and make sure that, accelerating is a mindset. But I would always just say to people, like, if you do the work and you've gotten that work out of the way, then that's ultimately what you're going to be trying to get towards.
Yeah. Yeah. Well, Charles, I think we're actually over time. This has been so much fun to talk to you and pick your brain and just learn about your approach to all of this. And I'm so looking forward to seeing what comes out of your company.
Mhm.
I think it's really wonderful. So thank you again for your time today. I really appreciate it.
Oh, and Chris, thank you for the opportunity. Like I said,
Yep.
it's great to talk about these technologies and kind of what's going on, and hopefully in the end, we'll succeed and make a little bit of an
Yep.
impact on tomorrow. So,
Yep. Exactly. Exactly. All right. Have a great day.
you too. Thank you.
Thanks.